Okay, so on to the next Codility lesson. This one's called Max Counters. This is actually a respectable task. The ones up until now have been painless. It's in counting elements, and let's get straight into it. So I'll start the test. I've got 120 minutes for this task. Let's get straight into it and see what we need to do. So I'm given n counters initially set to 0. I have two possible operations on them. Increase x, where counter x is increased by 1, and max counter. All counters are set to the maximum value of any counter. A non-empty array A of m integers is given. This array represents consecutive operations. So A is a list of operations, and the operations are either increase or max counter. If AK is x, such that x is between 1 and n, which is the length of the counter array, then operation K is to increase x. Okay, we'll look in the example in a minute. If AK is n plus 1, then operation K is max counter. Okay, so this A is a list of operations that we're going to do on our counter array. So given n equals 5, so we have 5 counters, and an array like this, this is what the consecutive operations do. So first 3, we increase counter 3 by 1, so we end up with 0, 0, 1, 0, 0. 4, we increase counter 4 by 1, so we end up with counter 3 and counter 4 increased by 1. Then 4 again, so now we have counter 3 increased by 1, counter 4 increased by 2, and then 6. Now this is n plus 1, so we set them all to the max counter value, which is 2. Set them all to 2. Then 1, we increase 1 from 2 to 3, and then we've got 2 lots of 4, so 2 to 3 and to 4. So that makes sense. So these are instructions that or operations that we do on this. If it's in the range from 1 to 5, we increase the counter at that index. If it's n plus 1, we just set them all to the max counter. The goal is to calculate the value of every counter after all operations and return that. Given the integer n and non-empty array A consisting of m integers, will return the sequence of integers representing the value of the counters. Okay, for example, given this example from before, we return the final counter values. Right, an efficient algorithm, I think that's going to be an important thing, because every time we receive a max counter operation, my instincts tell me that I'm going to loop through the whole array and set them all to some max value that we've recorded, but that's not going to be so efficient. But I'll think about that. So n and m are integers within the range of 1 and 100,000. What's m? Okay, I don't know what m. Oh, a consisting of m integers. Okay, so we can have 100,000 operations and you can bet one of the corner cases is going to be 100,000 counters and 100,000 max counter operations. So we have a very lot loop within a loop is going to be a nightmare. So each element of array A is an integer within the range of either 1 to n or n plus 1. Okay, so let's put the example into Eclipse and let's go for it. So the example is n equals 5, and here's our array, and this is the method that we're writing. So I'm just putting the example from the description into the solution and outputting the result. So what am I going to do? So I'm not going to worry too much about this efficiency for now. I'm just going to do the solution because I don't have any idea what I'm going to do about the efficiency problem, but it's a respectable puzzle, so I'm sure that I need to think about it. But I'll think about it. Hopefully I'll come up with an idea as I'm doing the basic function. So I'm going to make an int array counters, and that's going to be n digits long. That's how to define an int array. And they'll get initialized because it's primitive data types. They'll get initialized to all zeros. So I'm going to set a counter array to 5 zeros. And then I'm going to loop through the operations. I equals naught, I is a dot length, I plus plus. And get the operation out of there. Now if the operation is n plus 1, then this is max counter, else is increment. Now I'm going to subtract 1 from the operation. This could be done more efficiently in reduce 2 lines of code to 1, but I'm not worried about efficient solutions as in less lines of code. I'm worried about looping within a loop. Now I'm subtracting 1 from operation here because this A it's said in the description that A will be between 1 and n, whereas of course Java arrays are indexed from 0 to n minus 1, so I'm just going to subtract 1 from it there. And here we just go counters. Operation now points to the index plus plus. The max count operation is the thing that's going to be inefficient, and why it's going to be inefficient is because we're going to loop through the entire array inside the loop of the entire array. Now to make it slightly more efficient so I don't have to loop through it twice, I'm going to say int max value We'll start that off at 0, and every time we update a counter, say max value equals the maximum between what it currently is and the updated value. So here, when we call max counter, when the operation is max counter, this is what I am certain I don't want to do, but it's the only thing I can think of at the moment, is j equals 0, j is x, and counters.length j++, and set all counters to max value. Now that is my solution at the moment. I'm going to test it, but I'm not going to submit it. Like I said, this lesson is a respectable lesson, and so it's not going to be as simple as that. And I'm fairly sure that this will pass on, assuming I haven't made any little errors, which I may have done, which I'll check by debugging. But assuming that the logic here is correct, I think that the correctness of the test is going to be 100%, but the efficiency is going to, or the performance is going to be only good on small sized arrays. Like I said, the N and M are between 1 and 100,000, and I'm pretty sure that one of the tests is going to be an array 100,000 wide and 100,000 max counter operations. So we have 100,000 to the power of 2 loops, and that's not going to give us a good efficient result. Now I'll just test this and see. We get 32242, and what we want is 32242, so that is working, but it's inefficient. Now I'm thinking, if we just keep track of max value, and instead of actually, okay, I'm gonna keep track of max value, and I'm also going to have a minimum value. Now the minimum value is going to be, it's going to start off at 0, but when we do the max counter operation, I'm just going to put some comments in here. There's the increment operation. It's the max value operation. Now when we do the max value operation, instead of looping through the array and setting every counter to the max value, I'm going to just set min value to max value. In other words, the minimum value in the array is now going to be max value. So anything in the array which is less than the minimum value should be the minimum value. Now when I increase, I want counters first. I want the counters at that index to be the maximum of what it is plus 1 and the minimum value plus 1. I can get rid of that line. So what I'm saying is this counter should be, it should either have 1 added to it like we were doing before, or it should be the minimum value plus 1. So this counter at this index is now correct. What is not correct after having done all of this is any counters that weren't increased. So at the end I just need to loop through the counters and set them all to be the maximum of themselves and the minimum value. Okay, so does that make sense? If it makes sense to you, then that's good, because I'm not sure it makes sense to me, but I think it's right. So what I'm saying is when we do the max value operation, I remember what the minimum value in the array should be. When we do an increase, if the value is currently less than the minimum value, I'm going to set it to the minimum value plus the increase. If it's currently greater than the or equal to the minimum value, then I'll increase it as normal, and at the end I'm going to loop through the whole array and just make sure counters length I plus, just make sure that counters I equals math.max what it is and min value. So any that have not been increased since we did the max value step will get brought up now. So hopefully if we debug that, it might make more sense. So I'm going to debug through the default solution, and I'm going to say what I expect to see after each operation. So max value and min value is 0. Counters is 5 lots of 0. The first operation is 3. So I want the third index, which is actually index 2 because of indexing from 0, but we want this value to be increased by 1. So we want the result to be 0, 0, 1, 0, 0. 0, 0, 1, 0, 0. The next operation is 4. So we want this value increased, so we want 0, 0, 1, 1, 0. And that's what we've got. By the way, max value now we want to be 1 because we've set something to 1, so just check max value is 1, min value is 0. The next operation is 4 again, so we want 0, 0, 1, 2, 0. And we want max value now to be 2, min value is still 0. That's right. That's right, min value is 0 because we've not seen a max operation thing yet. Max counter operation. The next operation is 6. Now this is a max counter operation, so min value becomes 2 and we leave the array alone. So now we've got 0, 0, 1, 2, 0, but actually min value is 2. So if we run our loop at the end, we'll have 2, 2, 2, 2, 2. But we've got 0, 0, 1, 2, 0. The next operation is 1. So we want to increase this to 1, but the minimum value is 2. So anything which is less than 2 should really be 2. So what we're going to do is we're going to get this value right, and that's going to become 3. So we'll end up with 3 0 1 2 0. 3 0 1 2 0. That's right. The next operation is 4. So we're going to increase 1 2 3 4. This one, that's already 2. So we're going to increase that by 1. So it'd be 3 0 1 3 0. And the next operation is 4. How many operations have we got left? This, I think, is the last one. So that will increase this to 4. So it'd be 3 0 1 4 0. Now the minimum value is still 2. Maximum value we've been keeping track of is 4, but we don't need it now in this particular loop. Now we're going to loop through all the counters. Counter 1 is 3, although it's actually counter 0, but the first counter is 3. The second counter is 0 now, but the minimum value is 2. So it becomes 2, 3, 2. Then the third counter is 1, the minimum value is 2, so it will become 2. So we want 3, 2, 2. The next counter is 4, which can stay the same. And the final counter is 0, so that should go to 2. So that 3 2 2 4 2. And in big O notation, I think the efficiency is O2 because we've looped through the array. Because it's only the loops that matter in big O notation. So we've looped through the array once here and again there. So let's think of corner. 32242 is the correct result. Corner cases, N and M are integers in the range of 1 to 100,000. So I think the corner cases really are just massive values. We've got at least 1. What would happen if we just gave it it wouldn't matter if there was just 1 value. There's nothing funny. If there were 0 values, I might worry about that, but I don't need to because N and M are 1 to 100,000. Each element is within the correct range. That would be important because we could get an index out of bounds exception, but I know we're not going to because it says the values are all in the right range. So I think that is it. I could test some other cases, but I don't think I need to. I think it's a respectable solution exactly because I was really stuck thinking about what to do, and I was going to loop through here and probably get 60%, but I'm hoping that this will give us 100%. There may be a more efficient way of doing it. If you can think of a more efficient way, then leave it in the comments. I know these sorts of exercises are, they do attract comments. If you think you've got a better way, then leave it down there because it will be really interesting. And also people watching this video to learn how to do this sort of stuff. If you can teach it, if you've got a better idea, then leave the comments below. And if it works, then that's very good. I won't be offended if you can beat me at this. So let's run the tests. Okay, that's good. Now do I submit it? Let's submit and let's see what I score. I'm hoping for 100%. It's taken me 26 minutes. It's taken some time to evaluate, so I think it is putting some big arrays in there. And 100%. Now I'm quite happy with that. I'm sort of quite proud of that, because I was worried that, wow, well, I kind of expected 100%, but when I started the task and it was respectable, I was a little bit worried that the only thing I could come on, yeah, it's n plus m, and yeah, n being the width of the counters, is it, and m being the number of operations. So yeah, I was a little bit worried because I was really stuck to think of what I was going to do to get out of the n squared sort of thing. But there we go, we have 100% on that task, and I'm happy with that. Like I said, if you've got any other ideas, there's probably another way, there may be a better way. If you've got a better way, leave it in the comments below. And if you like the video, then if you haven't already, then subscribe to my channel, because I'm intending to carry on doing these Codility tests. They're quite fun and they help sharpen up my skills a bit. So thanks for watching.